Hi, hello, this is Jenny. Today's session is digital electronics. In this part, we are going to see about logic gates. Okay, let's move on. Logic gates means in the motherboard, the circuit, all the gates will be joined like this. Okay, so you can see in this picture. And next, what are the logic gates for in digital? Okay, let's see one by one. So logic gates, why we are using? Because we are using that circuits transmits our data. Okay, so if you want to transmit our data from one part to another part, we should set up that circuit. Okay, so without hardware, the software can't run their applications, right? So we need both hardware as well as software. So full and full, the digital electronics is full and full cover the hardware topic. Okay, so here we are using gates, flip-flops, registers, okay, and other diodes. Okay, so everything we can make in this board, circuit board. Okay, so here we are going to use two switches, switch panel. Okay, so here you can see that is on mode, off mode. Okay, 0 means off, 1 means on. So they are building blocks. Okay, so we are going to make, or we are going to run block of applications, okay, by using of this circuit board. Okay, next, what are the logic gates? So here logic gates, it means when you are turn on the position means that condition is true. For example, I'm running a flight. Okay, so I'm going to take off my flight means first of all I should check the condition of my flight. Okay, so what are the requirements we need when I run the flight means I have to check all the paths, okay, from bottom to top level. Okay, so bottom level we have to check the fuel level as well as that everything digital map circuit is covered in that running flight mode. Now so flight mode we have to check each and everything, air, fuel, as well as technical wise we have to check. Okay, for example, AC buttons, and then seating arrangements, and lighting and weather conditions, and speed up. Okay, so speed condition of my flight, engine level. Okay, so engine speed up. Okay, so everything I have to check, so then only I can move my flight, okay, from ground level to sky level, right? So that's the same methodology here we can apply in this logic gates. Okay, so there also we applied that gates method. Okay, so all the buttons when I run the flight means I'm going to switch on the button. Okay, so when we start my car I'm going to switch on the key. Okay, so all are digital circuits. Okay, so here you can fit on or off mode. So I'm going to start my engine. For example, I'm going to run a flight means I'm going to start my flight engine. Okay, so that engine shows the speed level, okay, and climate condition, and what are the passengers level, and capacity, fuel level, everything, weightage. Okay, so everything it shows to me. Okay, so that condition is on, I'm going to check that condition is on. If I don't check anything, it's a full and full off condition, that means freeze means off position. Okay, that condition is 0. Okay, so next example, so I'm going to on my slide, so I'm going to start the button, which means I'm going to give the input. Okay, so that gate, for example, terminal 1 and terminal 2, both the inputs should be same. For example, I'm the pilot and co-pilot, both should be the same position to run my flight, right? So that input should be same. Okay, for example, here I give the input 5. My co-pilot also should give the input 5. Then only my flight engine will get start position, right? And next, if I give 5 position, terminal 1, I give the 5 position, that means on position, but my co-pilot, he is giving off position, means what it will happen? Yes, so that engine will get stuck at that moment. So at that point I can't take off my flight. That time it shows some technical issues. Okay, so automatically some speed it will move, and after that it will get stuck or stop. It shows some indicator messages to the pilot. Okay, so then I will inform to the ground floor staffs. Okay, so I have some technical issues on my flight when I run the flight. Okay, so I will inform this message to the ground level staffs. Then they will check through the system. Okay, through the radar system they will use in the flight running mode. Okay, so that system we are using digital technology flight. Okay, and then next position. So here you can see this picture. The first one is both inputs. Both inputs are same, means I'm going to take off. If I give one input is right, another input is wrong, means I will get technical error, technical issues. I will face the technical issues on my flight or device. Okay, anything you can take, but it should be a digital circuit. Okay, and next, types of logic gates. So here you are going to see four types of logic gates. First one is not, and so we can consider like this. Okay, and alphabetical way, and, or, not, XOR. These four gates are very important. Okay, they are playing vital role in this circuit. Okay, so here you can see all the circuits. We will call it as Boolean logic. Okay, so Boolean means zeros and ones. Okay, here you can see these gates. For example, these are gates connected with AND gates, which means each and every gate is totally different from the other gates. Okay, next, first one is AND gate. Why we are using this AND gate? Because we are going to make some digital circuits. Okay, so that's the reason I should implement this gate on my circuit board. Okay, the AND gate means I should use this input. Okay, so here you can make AND gate. How you can make? You put like this. So this is your input. Here you can get the output. For example, two inputs. Okay, two inputs. What are they? On, off. The same thing. Okay, so input one. Okay, you are giving on position. On means on position. And second input also you are giving on position. It means 1. So you are getting output. What output you will get? Yes, both switches are on. You will get the output is also on position. On position means the value is 1, right? So here you can see this example, right? The first input 1 is 1, that means on position. Second input also on position. You can get that output on position. And second stage, only one input is on, another input is off. What the result? Yes, you can get failure. Okay, so this is your off position. Next, third stage, both inputs, input 1 and input 2, both inputs are off position. You will get the output off position only. Okay, that means failure position. Okay, so what is exactly we can get from this AND gate means if the both inputs are true, okay, then only you can get the true output. Otherwise, if you give only one input only true, that means on position means you can't get that full output. Okay, you can get failure. Okay, so that's why I said the flight example. Okay, so both pilots should give same input to the engine, then only it will take off. Otherwise, if one pilot will give the right position, another pilot uh, gives a wrong switch means what happen, what it will happen, automatically the engine will get failure. Failure means the flight will go down. Okay, so we can't take off. That is the technical issues we are facing right now. Okay, so that's why I said that example to your understanding. Okay, so that particular real-time example we are using that gates and gates. And gate means both inputs should be the same. If any one of the input is false, you will get the false input. Okay, and next, truth table. How we can specify this table? Okay, if you ask this question means that query answer is here. You can see, for example, that inputs both 0, you will get the answer 0. If any one of the input is true, nothing, AND gate. Okay, for AND gate result you will get failure. What condition? The condition should be both should be the same. Okay, then only you can get that answer is true. Otherwise, wrong. So that is the condition of AND gate. That's why we are using this gate in circuits board. If we are using this AND gate means all the inputs should be the same condition. Then only it will produce the output. Otherwise, it will produce the false output. Okay, and next, OR gate. Okay, so OR gate condition, why we are using this OR gate? Here also we are using two inputs. Okay, for example, here you can see that gate method you can draw like this. Okay, so this is your input. For example, input 1, input 2. Here you can get that output. Okay, for example, here I am passing only one input. For example, both inputs are true. You will get the answer true. Yeah, same like AND gate. Right. Okay, so that condition is right. In OR gate also, you can get the same result like AND gate because we are giving the both inputs are the same condition. That's why you are getting the result also same. Okay, there is no false statement or false output. Okay, and next, if any one of the input is true, okay, that condition also is applicable on the OR gate. Okay, but AND gate you can't do that work. AND gate means should be the same, but OR gate you can give any one of the input should be the true. Okay, so any one input it is on position means the output you will get that on position. Okay, if both inputs are failure, will get the same answer failure. Okay, because we don't pass any circuit. Okay, we don't pass any data, we will get the no data. Okay, so if you are having single data, which means you are sending two packets, you can send only one packet. Okay, other packets no need to send. If you are sending two inputs, that means positive and negative. Okay, so it will on it for the one input condition. Okay, so here you can pass this one input, but AND condition we should pass only two inputs. Okay, and next, what is the truth table of this OR gate? Okay, so here you can see both inputs are off. You can get that off position. Next, if any one of the input is on, yes, the switch is on. Okay, the condition is on. If next stage, if any one of the input is on, you can get that on position. Both inputs are, you can get on position. Okay, so that is the truth table of this OR gate. Okay, and next, XOR gate. XOR gate means here the short form of exclusive OR. Okay, so here what we are going to do, XOR needs only one input, that means on or off. Okay, for example, both inputs are on, XOR is off. Off, if the off condition means both inputs are off. Okay, here only both inputs on means the stage is also off position. When we are passing off position, off condition means you can get the output also off position. Okay, so here you can see this gate, you can draw like this. Okay, so two inputs, for example, both inputs are true. What is the result? Half. Okay, if any one of the input one on means you can get on position. Okay, so that is the benefit of XOR gates. Okay, OR gates, any one of the input we can pass, that time we can get the on result. Both inputs if we pass on position means you can get that on, right? But XOR gate is totally different from OR gates. Here we can pass only one input is true, you can get the true output, but it's totally different from this OR AND gate. Okay, we pass both inputs are on position, we will get off position. Okay, that is the usage or use of XOR gates. And next, what is the truth table of this XOR gate? Okay, here you can see both inputs off position, you will get the answer off. Here one input is true, another input is off, you can get the result on position. But here you can see both inputs are on, the output is also off position. Okay, here any one of the input you can get output. Okay, but both inputs are true condition means you will get the result that is off position. Okay, here you can get both inputs are on position means you will get on position. Okay, yes, right. Here both inputs are on means you will get that result is 0. Okay, that is your output. Okay, and next, stacking logic gates. For example, here the logic gate can be an input to another logic gate. Okay, so why they are creating this type of gates means all the gates we are going to make a tree. Okay, so each and every gate should depend on the other gate. For example, here you can see NOT gate connected with OR gate. Okay, this OR gate connected with another OR gate, so that is called stacking logic gates. Next, for understanding the examples. Okay, here I'm going to pass only one input, that means on position, to the NOT gate. Okay, so NOT gate diagram like this. The circuit board should be like this when we are using this NOT gate. Another input is 0, you can get that result output on position. Okay, and next, this is for not gates condition. And next, here we are going to depend another gate. For example, the NOT gate is depending on the AND gate. Okay, so here you can pass this input on position, the output is off position. Here you can pass this input on position, through AND gate you will get the result of position. Okay, so here we are going to concatenating the two gates, which means NOT and AND gate. And next, another example. Here I am concatenating C gates and or XOR. Okay, so I'm passing two inputs. Okay, so both inputs are true, you will get that true condition. AND gate, right? OR gate, if any one of the input is true, you will get the result also true. That's right. But XOR gate, what is the result? If both inputs are true, you will get failed. Okay, that is off position. So this is the function of this gate. Okay, the AND gate where can be used, OR as well as XOR gates. Okay, so in real time example, you can see the gates how they used integrated circuits. Already I said IC. Okay, so how many pins? 7 bits, 8 bits, 4 bits, 4 bits. Okay, this is 4 bits, 4 bits IC. What is bits? Bits, simply we can call it as 0 or 1. That means on or off. Okay, so in which generation they were used this integrated circuits? Second generation. Second generation means that 40s and 50s. Okay, 1940s and 50s. They were developed, they were implemented this type of integrated circuits. Okay, so 8 bits we can make. Okay, 8 bits means 1 byte. Bits is nothing but zeros and ones. That means on or off position. So for that implementing, for that developing, we introduced that gates in our circuits. Okay, so this is the real time where bugs. Okay, so today's topic is over, I think. So these are the gates in our digital electronics. Okay, so thank you so much. Bye from Jenny. We will meet on other session. Okay, thank you.